So on the next section, right, we are going to learn about the AWS infrastructure, how it's being designed within the AWS, and what all are the key components that we need to understand while moving forward. So let's get into this AWS infrastructure. The first one. So this is the pyramid showing how the data centers has been aligned within the Amazon Web Services. So on top of this tree structure, it starts with the region. Followed by the region, we have availability zones, and followed by the availability zones, we have data centers. So what is this a region, right? What is this availability zone? So a region is considered as a concept within this AWS Amazon Web Services that is a physical location around the world that where they have clustered the data centers. So each group of the logical data centers are called as the availability zones, and the cluster of the availability zone is known as a region. For example, if you consider one region like US East 1, which is a Virginia region, within this Virginia, there will be a couple of availability zones within that specific state, and also by the nearing state. All those availability zones are considered to be as region, and that's how it's being called. Each availability zone used to be a set of data centers. So what is this availability zone? So availability zones is also, as I mentioned, this is a set of data centers that have more power, networking, and connectivity within an AWS region. So with this capability, right, AWS was able to operate high-level applications and database in a more highly available, fault-tolerant, and scalable pattern, which means if you have launched a web server, if you want to have a server with high available, which means if something happens, a natural calamity happens to one region and destroy all the data centers, but you still want your server to be up and running fine, what we used to have is like a high available pattern, which means we'll launch the exact replica of the servers on 2 different availability zones within a region. Okay, so what happens is, like, when one availability zone is down, it doesn't affect us all at any, because there is still a replica of the same server on a different region that will still serve the content and still serve the request. And because of this scalability and elasticity features, we can still increase the count of that servers, and we'll wait once this the fallen availability zones comes back online. So that's where it comes with this high availability concept that plays within this region and availability zones. And also, all availability zones in the regions are interconnected with high bandwidth, low latency networking, and fully redundant and dedicated microfiber cables. All the traffic between these availability zones and between these data centers are encrypted, end-to-end encrypted, which means no one will be able to get any details, like an outsider or a third party won't be able to see and decrypt any of those details that's been transferred between these availability zones and those regions. So this is more of a graphical representation of what we actually discussed. So you see that a separate buildings that's been shown in this image. These separate buildings can be taken as an AWS data centers. Availability zone is considered as a collection of these data centers, and collection of these data centers is considered as an AWS region. As you can see, we can see those all are interrelated each other with low latency, resilient, and fiber connections. There are multiple availability zones in AWS region, as we discussed earlier, and also we had that discussion on the chat. Some availability zones have 2 regions, some availability zones has 3. Some region have 3 availability zones, some region have 2 availability zones. Depends on that region specific. Availability zones consist of 1 or more discrete data centers. As I mentioned, for example, if there's 1 available zones, there will be 2 data centers, 3 data centers. That we don't know. That's totally dependent upon the availability zone section. So all what we have visibility is on the region and also the availability zones. For example, if US East 1 is a region, the availability zones will be like US East 1A, US East 1B, US East 1C. That's how the availability zones has been segregated from the region. So as we discussed during the start of the session, right, we mentioned that not all services will be available within all regions. Out of the regions that we have currently, North Virginia, Ireland, and Singapore are the regions with the most service support in their continents. In the other regions, not all services of AWS are supported and that are in progress. If you look on this map, right, you can see all the blue dotted ones that are the available ones, and the orange dotted ones that are the ones that are in upcoming ones. And next, this is the AWS infrastructure availability zone structure, how it works. So if you look at this, this is the center, this is the center orange dot can be taken as a region. Within that region, we used to have availability zones. Availability zones is just a cluster of data centers. Availability zone usually used to have a distance between 60 miles from each other, because as I said, end of the day, it's all these servers are going to be hosted on some of the infrastructure. There might be damages caused to that infrastructure, might be due to nature calamities, network problems, power outages, anything, right? We can't define it. So they don't use to, they won't use to have availability zones within nearby range. So the condition is that it should be 60 miles apart from each availability zones. Okay, the AWS availability zones infrastructure. Okay, as we discussed, we've been going through the what's availability zone, what's region numerous time, right? High availability, how it's been placing, what's the impact of regions on our web services, right? So an availability zone is a facility where the data centers are located. As we discussed, we saw that there are multiple data centers. A cluster of the data centers is called to be a availability zone. Okay, there are currently 81 availability zones within the whole AWS structure. All availability zones in an AWS region are interconnected with metro fiber to have high response time, to have low latency. All traffic between availability zones is encrypted. Availability zones are physically separated by a meaningful distance, many kilometers from any other availability zone, although all are within the 100 kilometers, which means 60 miles of each other. AWS data centers. So end of the day, what we discussed, right? We've been saying that on-prem is used to be a bad thing. That's why we moved to cloud, things like that. So literally saying cloud is also an on-prem, right? What makes it different is like how we actually interact with the services. We are interacting with all those services via internet. That's the difference, and that's why the big concept of cloud. End of the day, the data is still stored on physical servers on an infrastructure. Okay, that's what he's saying. The data center infrastructure consists of physical or hardware-based tools and components. Data centers are where our information are stored, which means you are launching a web server, you have the code written, you have the thumbnails, you have the data, everything. Even though if you're pushing something onto virtual server, right, you can see it on your console, which means you can see it on a web page. Still, it needs to be written onto some physical server somewhere else in the world, which comes under a region, right? So that's what we've been dealing with these data centers, that all information is stored, how data centers are secure by design. So this is the infrastructure of a data center. This is like a high level overview. I'm not saying this is the exact picture of a AWS data center, but this is how a data center looks like. Okay, the perimeter level, the entry exit is being monitored and secured. The infrastructure level, how it's supported, the infrastructure, how it's capable of handling many type of circumstances. The data layer, how data is being processed and stored, and the environmental layer. So when talking with AWS, right, we've been talking that AWS is secure. I can say to my friend, like, okay, AWS is so secure that you can host anything on that. So secure, when talking about security within Amazon Web Services, it's actually a two-way communication. This is the level of security that Amazon Web Services provides to our resources. Okay, if I create an EC2 instance, it's an EC2 server. Okay, it's just like a virtual machine. If I create an EC2 instance, that might be going to be installed on some of the servers over here, what we see at the data layer. Okay, who all will be having access to this data layer physically? Who all will be access to this perimeter? Who all will be access to this infrastructure? We don't have access to that. We can't comment on that part. Okay, that's totally managed by AWS, and it's within this AWS agreement that no one would have access to our data that's sitting on these servers. Okay, that's the agreement. That's how we've been dealing stuff with. That's the security what they're taking. If someone tries to someone tries to go through all those security measures and they were able to access the data within the data center, which won't happen. But in that scenario, AWS is the one that's going to be blamed. Okay, that won't happen at all, because the strict measurements, the cautious that AWS has taken, not only AWS, any cloud providers or any on-prem data center providers have taken, is extremely high, because the data what they're dealing is like different kind of data, and if something goes wrong, the level of problems they are going to face, the legal liabilities they're going to face is huge. So that's why they don't play anything with those infrastructure security level. Everything is taken care by them. So what is a security level that we manage, right? So I have an EC2 machine, a virtual machine that I've been launched. I create an SSH key. SSH is a key that used to log in onto the server virtually. So using that SSH key, I have the permission as an admin access on my web server. I can post whatever I want. I can post my pet's photos on the web server that I'm running, right? So if someone hits my web server, I can see all the pictures and things like that. So I need to manage who all should access the server virtually, right? AWS don't have access for us. Don't look for the security on my AWS account saying who all will be accessing it, who all I have given access to, right? So for example, I misplaced a key, I placed that SSH key onto some public Git repo, and someone got that access to that key. And the security groups on the EC2 instance I opened to whole world, which means anyone with that key can access to the server. They can literally use that key and log into my server and manipulate the server and can cause damages as they want. They can post anything what they want. My website will be having the wrong images, the wrong content, everything will be down. That's what we are talking about, the hacking and the things that goes wrong, right? Anywhere there will be a security glitch, there are people always monitoring our environments to see what's going on, and they're trying to get a chance to break into it. So these are the two types of security measures as a shared responsibility model that AWS and as a end consumers as we need to take. Who all will be having access to the server, who all will be virtually accessing it, who all have the admin access to the server that we need to manage. Physically, what all permissions that needs to be taken care of, network level, everything, AWS manages it. So that's a kind of high level talking about the security management. It's not like AWS will take it everything from their end. That's a kind of high level overview. So any questions on the security part? I know that's a kind of big elaborated one, but if you have any questions, I'm so happy to get it discussed. So an edge location is where the end user access services located at AWS used for caching content. The next one, as I said before, right, we will be dealing with different terms. Caching. It's like, for example, if you look at this picture, right, it's like a clear example. Okay, the user hits on a website called example.com. Okay, once it hits the example.com, it goes to the nearby edge location and it will search for that example.com domain details. It can't find it because it don't have the details. What it knows is like it knows where to go and fetch those details, the Amazon edge location. So what happens is like it will send that request to its backend server. That might be an Amazon S3 server or HTTP server, whatever it is. Over there, it will resolve that request. It will send on to that edge location. Along with responding the request back to the user, right? The edge location will also cache it. Caching in the sense, it also cache the process data, as Ashmi mentioned. It will save that copy over here, so that when there is a request for the same website on the next time, it don't need to go back to the backend server. Okay, so that it can reduce the processing time, it can reduce the latency, and can respond it back to it. So saying on edge caching in the sense like, it's not like it's going to cache that content for all the time. For example, I did make some changes to the my web page content, right? While I'm doing the change to the web page content, I will also initiate a cache clear on the edge locations, which means all the data that's been cached on the edge locations will be cleared. And if the user hits example.com again, it will comes to the edge location and will see there's no details for example.com. So I need to go back to the backend server. It will go back to the backend server, fetch the latest one, and will update the edge locations. So that's where the caching comes into place. That's where it helps in edge location, and also in so many other scenarios that we are going to deal within these AWS services. So that's what caching used to do. we will deal with so much of developers issues that they are dealing with caching and things like that. So that's the overall concept of edge location. It used to cache the content so that it can reduce the response time, reduce the latency, reduce the duplicate requests going back to the backend server, so that it can also free up the backend server and also increase the processing. Caching helps with faster processing and lesser load on web server, etc. Yes, that's true, Ashmit. Yes, backends more processing on the backend server. So as of now, we have 218 plus edge locations for the AWS infrastructures for these edge locations, mostly being used for CDN, the content delivery networks, and Route 53 domain services like that. The next one, what we have is the AWS Local Zones. So AWS Local Zones are a new type of AWS infrastructure deployment that places AWS compute, storage, database, and other selected services closer to larger population, industries, and IT centers where no AWS region exists today. So just think in a scenario like this. For example, there's been very huge traffic for a website in Florida or something like that. I'm just throwing out an example, okay? That doesn't have a region nearby, but it have a region on the other side of the states. So in that kind of situation, to have high response time, to lower the latency and things like that, AWS have the option to have the local zone if they have available on that specific region. So that's where AWS local zones comes into place, where no regions exist today. Each AWS local zone location is an extension of an AWS region. It have the same content, same networking backend, everything. It's just going to be an extension of an AWS region. AWS local zones is now available in US in 11 different locations.